Hi everybody, in this video we will learn about polyatomic ions, the same polyatomic ions that you have memorized many times, taken quiz, did very well on it. Doing the dot diagram of polyatomic ions is no different than doing the dot diagram of other covalent compounds. The only difference is that since it's an ion, so it has gained or lost electrons. So because of the gain and the loss of electrons, we will just do the math a little bit carefully. The rest of the story is the same. So nitrogen has 5 valence electrons and hydrogen has 1 valence electron. I have 1 nitrogen atom and I have 4 hydrogen atoms. So that gives me 5 and 4 here. And this plus 1 means I have lost 1 electron. I'm going to subtract that. So let's add first. I have a total of 9. So I'm going to subtract 1. That gives me 8. You know, the subtract 1 because you have lost 1 electron. So that's why I'm subtracting 1. Okay, so total was 9 minus 1 is 8. You always divide by 2. It gives me 4 pairs. So once it gives me 4 pairs, the rest of the story is pretty simple. You know, I put nitrogen, whoever is 1 atom is in the center. And then I have 4 hydrogens. Okay, so 4 hydrogens go in 4 corners. And I used all my 4 pairs. 1, 2, 3, 4 pairs. Now to put this thing in parentheses and plus 1 here, because to make this dot diagram, I have lost an electron. Okay, so instead of figuring out where the electron has been lost from, we will just do the math. So overall in this whole dot diagram we have lost 1. So let's do it again. Oxygen has 6 valence electrons, multiplied by 1 oxygen is 6. Hydrogen has 1 valence electron, multiplied by 1, it is 1. So how many I got here? 7. Now this negative 1 is telling you it has gained 1 electron. So you add that 1 here. That gives you 8 divided by 2. It gives you 4 pairs to play with. So I have 4 pairs to play with. So I have oxygen, and one pair I use for this hydrogen, 1 pair I use for this hydrogen. So I have 2 more pairs, and then those 2 pairs are going to sit as a lone pair. You know, we've learned this, that these are called lone pairs, okay, or free electrons. These are the free electrons or lone pairs, and these are called bonded pairs. So I have 2 bonded pairs and 2 lone pairs. So let's move further on. Sulfur has 6 valence electrons times 1. Oxygen has 6 valence electrons times 4. So 24. So it's like 30. And then negative 2 means you gain 2. So it's 32. You divide by 2. You have 16 pairs to play with. That's a lot of pairs. Okay. So I have 16 pairs to play with. So sulfur goes in the center because sulfur is only 1, and I use the 4 pairs for 4 oxygens. Okay, I have 4 oxygens right here. So bonded with sulfur. Now sulfur already has 2, 4, 6, and 8 valence electrons around it. So I cannot add any more to the sulfur because 8 is the maximum that I can have. So I used 4 pairs. I'm left with 12 pairs. So I'm going to put the 12 pairs, 1, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I used all the 12 pairs to put lone pairs around oxygen because oxygen did not have 8 valence electrons. Oxygen only had 2 right here. So I put the lone pairs around it. So 2, 4, 6, 8, 2, 4, 6, 8. Everybody must get 2, 4, 6, 8, 2, 4, 6, 8. I think I forgot to put the hydroxide in the parentheses. You put hydroxide in the parentheses, minus 1. And the same thing will be here. So go ahead and complete this and show me this in class. Next thing we want to talk about is the dot diagram of ionic compounds. So ionic compounds are formed by the loss or gain of electrons. So somebody is losing, somebody is gaining. So of course the metal is going to lose, the non-metal is going to gain. So sodium has one valence electron, chlorine has 1, 2, 3, 4, 5, 6, 7 valence electrons. This is a sodium atom and this is the chlorine atom. Now what happens is that when they gain or lose, the sodium is going to transfer its electron to chlorine. So what happens, it becomes plus 1, okay, plus 1, and chlorine becomes 1, 2, 3, 4, 5, 6, 7 it had, and this one came. I'm just doing the X just to show that it is a different electron came from sodium, not that it matters. And so chloride, it becomes chloride ion. So when we do the diagram of ionic compounds, we must show 0 dots around metals, because metals always lose electrons, and we must show 8 valence electrons around nonmetals. So 8 around nonmetals, 2, 4, 6, 8, and 0. I have no, see, there was a valence electron that was given to chlorine, so it is left with no dots at all. And this one must have 8. But we don't show any lines, single, double, or triple. That was only for covalent compounds. So one more time, we have to show 0 dots on metals and 8 on nonmetals. So let's do another example. Aluminum. Aluminum has 3 valence electrons. Chlorine has 1, 2, 3, 4, 5, 6, 7 valence electrons, and I have 3 chlorines. So I'm going to rearrange it a little bit. So I will have aluminum in the center, and aluminum has 1, 2, 3 valence electrons, and I have chlorine on the sides, 1, 2, 7 on each side. Okay, now what's going to happen is that aluminum is going to give its electron to chlorine. So aluminum give these, this one here, this one goes here, this one goes here. So aluminum lost the 3 electrons. It has transferred. Okay, so aluminum is going to lose electrons because it's a metal. So metals lose electrons, and they are going to gain electrons. So what happens at the end is that aluminum doesn't have anything on it. So aluminum lost all the 3 electrons it has. Aluminum is positive 3. Each chlorine gained 1. Okay, 1 from aluminum. 7 they had their own, and they gained 1 from aluminum. So at the end, when you're all done deal, this is aluminum chloride, you have no or 0 valence electrons for metals, okay, and 8 valence electrons for non-metals. So make sure you have 0 for metals and 8 for non-metals. So that's all about loose dot diagram of covalent compounds, polyatomic ions, and ionic compounds. Next we will be learning about shapes. So that's all. Thank you very much. See you later.